Alrighty, week 4, day 2. Alright, well, we're going to start out by simplifying some radicals here. Well, we're multiplying radicals and then simplifying them. Remember, your square numbers, 4, 9, that's 2 squared, 3 squared, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. Alright, when you multiply two radicals together, you just multiply the two numbers inside the square roots together, so 10 times 15 is 150. And then, of course, the negative 3, if there were something to multiply it by, like down here, there is, you would, but there's nothing, so it's just a negative 3. And you look over here, is 150 divisible by any of these numbers? Nope, 25. $1.50 is 6 quarters. So this is negative 3 times square root of 25 times square root of 6. And just in the same way that we brought the two numbers together under the same square root bracket by just multiplying them together, we can break them back apart again. And why do we do that? Because the square root of 25 is a whole number. It happens to be 5. So that's negative 3 times 5 times square root of 6. Negative 3 times 5 is negative 15 times the square root of 6. I'll do one more for you over here. I'll let you do the other two on your own. Here, let's leave that one alone. We'll do that one. I'll do number 3. So let's see. Square root of 5 times square root of 5. Well, that is square root of 5 times 5, which is 25. And 5 times negative 3 is going to be negative 15. But square root of 25 is actually a whole number. That's 5. So that's 15 times 5. And 15 times 5 happens to be, let's see, 15 times 10 would be 50. And 15 times 5 is 25. 50 and 25 is 75. Don't forget your negative. Negative 75. I'll leave the other two for you. Alright, down here, find the measure of angle B and state the relationship. Remember, our different relationships were adjacent, which just means next door. We've got complementary, which means that they add up to 90 degrees, their measures. We've got supplementary, which means their measures add up to 180. And in this case, all of our supplementary angles happen to be linear pairs, meaning that they make a straight line when you put them together. Now, or we could have adjacent or vertical. In vertical angles, when the two angles come together and they make an X shape, the angles across from each other are vertical, like this. Alright, so let's take a look at a couple of these. Here, you can see this little right angle thing here says that that's a right angle, and since this straight angle here is 180 degrees, that means the other side is also a right angle, which means these are complementary. And then, if they're complementary, 28 plus this, let's see, if that were 30, then B would be 60, because 60 and 30 is 90, but this isn't 30, it's 28, so this is not going to be 60, it's going to be 62. So B equals 62. I'm going to be careful here. Measure of angle B. Down here, see the little square root bracket? So again, complementary, because the two angles add up to 90 degrees. So B, 31, add up to 90. If that were 30, then B would be 60. This is 31, so B must be 59. Measure of angle B equals 59 degrees. So I put a little degree sign up here. All right, I'll leave the other two up to you. All right, let's see. We're solving some equations here. Up here, let's see, we've got 9 plus x equals 3 minus 2x. So there's no like terms to combine. So our first step is to get all of our variables on one side. So you see we've got a variable term here, and we've got a variable term here. And then we've got, let's see, a constant term and a constant term there. And typically we put all our variable terms on one side on the left. You can do whatever side you want, though. Doesn't matter. So, well, let's get rid of this negative 2x on the right. So we're going to add 2x to both sides. Add 2x. And that's going to leave the 9 as is. And then x plus 2 more x is 3x. And that leaves the 3 as is. Okay. Next, we want to get this 9 over on the other side. So we're going to subtract 9 from both sides. That's going to leave the 3x alone. But the 3 over here, subtract 9, is going to be negative 6. And then we're down to, and notice at this point we're just down to a regular two-step equation. So 3x equals negative 6. We're just going to divide by 3. So that leaves us with x equals, and negative 6 divided by 3 is negative 2. We're going to go back and check our answers here. And we have 9 plus negative 2 equals 3 minus 2 times negative 2. So let's replace our x's with negative 2's. 9 plus negative 2. That's same as 9 minus 2. That's 7. And 3. See, minus 2 times negative 2 is actually a negative 4. And 3 minus negative 4 is the same as 3 plus 4, which is 7. Check, it all works out. Down here, hit another absolute value equation. Remember, absolute value means that whatever's inside these absolute value brackets is going to be 4 spaces away from 0 in the number line. So this could have two values. It could be 4 or negative 4, one of those two things. So we have to set up two separate equations to solve this. So we have 3m plus 7 equals 4. Or we've got 3m plus 7 equals negative 4. We're going to follow the same steps either way to solve this. And they're just two separate two-step equations. So we're going to start by subtracting 7 from both sides. So that leaves us with 3m, and 4 minus 7 is negative 3. And over here we have 3m, and negative 4 minus 7 is negative 11. Over here, our next step is to divide by 3. When we do that over here, we end up with, let's see, 3m divided by 3 is m, and negative 3 divided by 3 is negative 1. And over here, we divide by 3, and we get negative 11 divided by 3 is negative 11 over 3. And we're just going to leave it like that. We're not going to work that out as a decimal. So what that means is, if I substitute, and it's a good thing to check with your calculator, but if I substitute negative 11 over 3 for m, and I go 3 times negative 11 over 3 plus 7, it's going to equal negative 4, and the absolute value of negative 4 is 4. And or if I substitute negative 1, 3 times negative 1 plus 7, we can actually do this one pretty easily. 3 times negative 1 is negative 3, plus 7 is positive 4, and the absolute value of positive 4 is 4. So either way, we end up with a number inside the absolute value brackets, either positive or negative 4, depending on which one of these two answers we pick. So either of these could be true. Let's do another one over here. Alright, so whatever's inside the absolute value brackets is going to be 10 spaces away from 0 on the number line. So that means it could be a positive 10 or a negative 10. And so we set up an equation for each. 2p minus 6 equals 10, or 2p minus 6 equals negative 10. It's one of these two things. Same steps to solve each equation. We're going to add 6 first, and that's going to give us 2p minus 6 plus 6, cancels each other out. 10 plus 6 is 16. And then next door here, when we add 6, we get 2p equals negative 10 plus 6 is negative 4. Our next step is going to be divide by 2. So that 2p divided by 2 is p. 16 divided by 2 is 8. There's one possible answer. Next door here, 2p divided by 2 is p. Negative 4 divided by 2 is negative 2. So there's our second possible answer. We can go back and pretty easily check both of these two answers. If p is 8, we get 2 times 8 is 16, minus 6 is 10, and the absolute value of 10 is 10. Or negative 2, 2 times negative 2 is negative 4, minus 6 is negative 10, and the absolute value of negative 10 is also 10. All right? So check a couple of these out on your own. Good luck.